Good morning, afternoon, evening, everyone, depending upon where you are in the world, and welcome to the latest in the Open Group series of industry webinars. My name is John Mayer, and I'm the Open Group's Conference Director. Today, we are focusing upon increased cybersecurity resiliency through systems architecture. And before we get started today, I just have a couple of words of housekeeping information for you if you're not familiar with the WebEx platform. There are a couple of ways that you can communicate with us and with each other today. The first of these I'll draw your attention to is through our chat channel. If you look at the bottom right-hand corner of your WebEx screen, you'll see a little speech mark bubble. And if you click upon that, that opens up the chat channel. I'd ask you please to use the chat channel just for social interaction, discussion with each other. You can put any messages you wish in there. You can talk to each other in that channel. You can put your messages for everyone, and you can tell us where you've come from. You can tell us what you're thinking of the session, but any discussion or chat amongst yourselves, social networking can go in that chat channel. However, please do not put questions for the presenters into the chat channel. To post questions to the presenters, I'd ask you to purely use the Q&A channel. Now, to find the Q&A channel, if you look to the right of that speech bubble, you'll see another circle with 3 dots in a horizontal row in it. If you click on that, that gives you some other options, and you can open up the Q&A channel. Please, can I ask you, if you have questions for the presenters, just post them in that Q&A channel, and make sure you send them to everyone so that everybody can see those questions, okay? And the answers, if they're posted in that channel, will also go to everyone. But our intention today is to keep most of those questions and ask the presenters to answer those in person at the end of the 3 presentations that we're running today. So chat channel for just social interaction, Q&A channel, please, just for questions to presenters. Okay, it's now my duty to introduce our speakers today. So in order of presentation, firstly, it's Dr. Justin Pearson. Justin is Director of Systems Architecture at Lynx Software Technologies. Prior to this, Justin worked at MTSI as their Aerospace Systems and Digital Engineering Lead. Justin transitioned to Lynx to be more intimately involved in the realization of key Army aviation requirements, such as the aviation mission computing environment. Justin's doctorate is in information technology with a specialization in cybersecurity and information assurance. Then we have Tesfa Mael. Tesfa is lead software engineering development at wolfSSL, focusing on embedded security software, cryptography, secure boot, and TLS libraries. Previously, Tesfa played a pivotal role at Wind River Systems, where he contributed significantly to the VxWorks real-time operating system, tailored for avionic applications compliant with DO 178B. Then finally, this afternoon, or evening or morning, we have Doug Britton. Doug is Chief Strategy Officer and Director of RunSafe Security and a member of its Board of Directors. Doug plays an essential role in showcasing how RunSafe's technology changes the economics of cyber defense, and he has been instrumental in driving the RunSafe technology strategy and roadmap. Prior to RunSafe, Doug founded Caprica Security, which sold its Tachyon business to Samsung. He also managed large-scale security research, reverse engineering, and exploit development programs for Lockheed Martin and SAIC. So welcome to all of our speakers, and I'd like to hand over first to Justin. Thank you.
Hey, everybody. Thanks for joining us today. I'm going to kick things off here before I pass them over to the other much smarter, wiser presenters today. But I want to set things up for you with the Lynx picture and kind of why we care and why we sort of set a foundation of a partner ecosystem that involves companies like wolfSSL and RunSafe. Over the past year, especially, Lynx has morphed from your operating system provider, operating environment enabler to more of a full stack offer. And a lot of this reason is because most of the key enabling features that allow us to achieve rapid capability insertion and certifiable change containment, especially in the safety critical markets, it comes down at a much lower level of the stack. So part of the reason why I came to Lynx was to make sure I can sort of usher in that next phase of evolution, not only for an operating system or an operating environment, but key enabling features of the full stack. Because when it comes to the more cutting edge technologies that wolfSSL and RunSafe bring to the market, especially in terms of cybersecurity resiliency, we need certifiable change containment boundaries. And if we don't build the system certifiably, have the foresight for the pace of change that DoD especially wants to achieve, then we just won't get there. So this chart is really just to hit that home. The two most recent acquisitions involved Thompson Software Solutions, apologies for this barking dog, by the way, and Timesys. A brief overview from a Lynx perspective. We really want to power mission success, right? So improving the economics of how we develop software just kind of goes with this. But we certainly want to push folks to more modular building blocks based solutions. So you hear a lot of the Lego analogy in terms of the MOSA marketplace that we're trying to achieve. That's very much what we sort of model our message off of. So we want to deliver enabling features for the full stack, and push away from only this OEM exclusivity of requirements, right? Most of the time, levels we're talking about in the Lynx space with respect to how we standardize the binary interface, right? So how do we reach binary equivalency of things we develop in a cloud versus on a target? Those are things that typically the government does not stipulate. So we want to push those to the front and make sure that all our customers, in addition to the OEMs, understand how enabling those types of features can be. At present, Lynx is focused primarily on the DoD space, but over the past 30 plus years of that company's existence, it's been in automotive and medical and elsewhere. So in terms of Lynx Mosaic, the flagship product really is Lynx Mosaic, but the full stack picture is what brings in and it allows customers to take advantage of the operating environment that we set up. So again, building codes, message, change containment is key here. The other thing we want to help with is maximizing COTS, GOTS, and NDI is not as simple as it sounds, right? We want to do that, but we also want to achieve MOSA alignment. Well, those are somewhat at odds oftentimes from a requirements development perspective. So we want to achieve both objectives, but to do that, we need to make sure the change containment is sound. And of course, when you look at things like CI/CD pipelines, DevSecOps, all that, the virtual integration environment piece to that accompanies it. So we can have the best, most scalable building codes of anybody, right? But if we don't have the actual environment from a development verification standpoint for more than just one supplier to contribute to, then we really aren't doing our jobs any better than we have been in the past. And you can see the last bullet, full stack partner here. This is exactly why we want to develop technology the way Lynx is doing it, so that we can get the folks like wolfSSL and RunSafe that much more quickly, more effectively, efficiently, certifiably. You know that, right? Really quick success factors. I don't want to walk through each and every one of these because I want to save more time for some of the other presenters. But again, we want to simplify the building blocks. If you look at what acquisition typically has to experience, it's all upper right, right? You're welcome to zoom in on it, but the bottom line is that the acquisition process is quite complex. So when we looked at the new acquisition approaches that the DoD was pushing forward, things like the software acquisition pathway, we asked ourselves, well, how do we allow that to occur, right? Because the typical process has been, well, you're one major contractor, rule them all, and you may have hundreds of configuration items that involve software that all flow up into that one contract. So not only are the contract strategies at odds, but just in terms of the acquisition guidelines, right? A lot of red tape involved to get there. So what can we do to make sure our technology, in terms of deployment options technically, can be delivered in the same modular fashion to enable the software acquisition pathway mindset, right? So we really want to have those boundaries standardized, especially when we look at things like AI and ML. You know, the environment is getting more variable, it's getting more dynamic, and they're trying to field things more rapidly. So whether it's manned or unmanned, especially in aviation, there's always the element of safety, especially now with more security risks being introduced. So we just have to do what we can on the front end to make this easier for our customers. The most objectives is important to this. Again, just want to provide it for reference, but this is the perspective that helps us shape our offerings to not only our industry partners, but the government itself, right? If we don't have the perspective of what the government is trying to achieve from a modular system, open systems approach standpoint, then we really can't provide those key enabling features to implement something for safety or for security. So you're welcome to read through these. These will be provided by the open group post this meeting, but In any case, I want to make sure everybody can lay eyes on these, because I think any sound solution, any sound consensus message to a customer, especially in the DoD, it must align with their top level objectives for what they're trying to achieve, especially with respect to MOSA. A little bit more on the Lynx solutions. Well, one day I'm going to make this chart into a sort of caveman image, right, where you can show, fish out of water leading into a man, right? So regardless of the evolutionary picture, what we're trying to show here is that the product is becoming more simpler, right? Because the environment and the needs are becoming more complex. So the more, there's a saying at Lynx, especially with, and it's not original to organic to Lynx, but it's really from academic papers. The more complex the solution, the simpler your building blocks have to be. So you can see in terms of the evolution of the product, the one operating system to rule them all mindset, go find a BSP and a target that is in alignment and support and it's certifiable. It's not going to cut it in the more rapid paced environment of the future. So really what we're trying to do is get to the point where we have clearly identified for the customers what boundaries we want to worry about. So your one-to-many versions of a standard can live in a sort of virtual space certifiably on one-to-many hardware targets. We can minimize software change impact analyses. We can minimize hardware obsolescence risk, so on and so forth. And then we can balance that for customers as well, right? So we have a concept of unikernel. We call that Lynx element within Lynx Mosaic. Lynx Mosaic is that configurable, set of deployment options. It's not an RTOS. An RTOS is one of the deployment options. So the unikernel is really that next evolution of a derivative of that RTOS, and it simplifies those building blocks. So whereas before you had multiple processes, multiple threads, now you have single process, multi-threaded in a virtual space, in addition to a sort of tiered scheduling structure. So bottom line with this is we've continued to evolve, and what it's led us to is simpler building blocks. And it's these building blocks that allow us to get to partners like wolfSSL and RunSafe much more effectively for our customers. Just really quick on this chart, I just want to hit home. Operating environment is one thing, getting to partners is one thing, but making sure you have an environment, you have tooling, and you have automation involved to sustain and support all those things is something else entirely. So definitely welcome to have more detailed conversations on all this with respect to the Lynx vision to it. But in any way, you need not only the implemented solution, but like I said, environment, the telemetry, the observability, traceability, and you need to automate that as much as possible so that you can get it out the door routinely. And it's really all these things that segue into the next presentations you're going to hear from wolfSSL and RunSafe, is if we can start with a sound operating environment that has the more effective certifiable isolation approaches, change containment, right? That message that I keep saying, change containment, please remember that. Then we can accelerate the products that we're trying to get out the door. And then we can have more contributors than we've ever had before in terms of the full stack offering, right? So this is just from a Lynx standpoint, but if we can simplify the building codes, we make them more understandable for third parties. So not only opening it up in terms of competitive offerings for the industry partners that we already have, but also the government itself who are looking to get things out the door that a high TRL today, not tomorrow. So in any case, I'd like to pass things off to wolfSSL to get into the next phase of the presentation. But thank you for the time, and we'll be available for questions at the end.
Tesfa, you're on mute, by the way.
Oh, thank you. Can you hear me now?
Yes, we can hear you now. Thank you.
Yeah, thank you. So WolfBoot provides a number of solutions for cybersecurity system architecture, and our software is used in different verticals, including avionics, telecommunication, medical, industrial, pretty much everywhere. If you want to secure data, you can use our software. And today I'll be covering a little bit about our company overview and the 0178C product that we have available, and specific customer use case on Intel Tiger Lake WolfBoot modification that we've made. So wolfSSL provides a TLS library, and in the core of it, if you want to secure 2 endpoints, you can leverage our software, and it provides a number of benefits. When people think of TLS, they think of OpenSSL, but we've got a lot of OpenSSL users that come to us wanting to use wolfSSL because we've got a library that's more modular, highly performant, and we've got an abstraction layer where you can run it and plug it with any OS. And it's the smaller footprint-wise, occupy 1 to 36 kilobyte ROM per session during TLS. Handshake is 20 times smaller than OpenSSL. And we've got our crypto has gone through FIPS 140-2 validation in DO-178 and MISRA. And we also provide 24/7 support. Essentially, we can secure data at rest using encryption and decryption. Data in transit, you could use TLS, SSL, or SSH. And the transfer medium, we don't really care about because we are at a higher level. And for preventing malicious firmware updates, you could use secure boot. And wolfSSL was founded in 2004. We work over 2,000 OEM customers, and we currently secure 2 billion secure connections. And we have a number of technology partners, as well as we support a number of open source projects. You can actually access the code if you go on our GitHub page. In terms of our product, we've got about 9 products, and WolfCrypt is the underpinning that is used by either TLS or Wolf MQTT, which is a lightweight MQTT client, or SSH for secure client and server, and Wolf TPM for lightweight TPM if you want to seal and unseal your secret, and for Wolf Boot to do a secure boot loading and update. Wolf Sentry is similar to for embedded IDPS target to protect an attack. And we also have a tiny curl, which is a smaller version of the curl, which is used by many operating systems for data transfer library. And we provide a number of language wrappers. So you can have a Python code, you can leverage our library. And we're dual licensed, commercial as well as GPL v2. So as an open source GPL v2, you can actually go to our website or our GitHub page, download the code, evaluate, test, and if you need a license, you can obtain one from us. We're a clean room TLS and cryptography implementation. So secure boot prevents running unauthorized software on board, which is a crypto signature is attached to all authorized software. So that way, an adversary cannot run their software on the embedded systems. And it's important because secure boot can help prevent your avionics systems from becoming $1 million brick. If you cannot access a target and it's been bricked and other software is running, that's quite dangerous. And it happened. We see it happening many times over and over again. So wolfSSL provides a key component for your cybersecurity needs. In terms of DO-178C certification, I actually came on board to help take the cryptography through DO-178C certification, so avionic customers can consume our cryptography. And usually for security software, it doesn't mean it's safe. And safety doesn't imply it's secure. So for something to be safe, and if it complies to DO-178C, no dynamic memory allocation, and you want to have a predictable execution flow in every single line of code, must be traceable, high-level requirement, low-level requirement, design, code, test result, and do coverage analysis and so on. So, for the longest time, the ancient mentality has been, if you ain't broken, don't fix it. But nowadays, with vulnerability management, when something breaks, we are prepared to fix it. In fact, if there's any vulnerability that is discovered, our average cure time is 36 hours, as opposed to other solutions where it may take them months. And we provide a number of cryptography. So we've taken a subset of our cryptography through DAL-A certification for hashing, for symmetric encryption, asymmetric encryption, as well as X519 cert verify. And this is missing a CRL on the list as well. And it can be expanded and trimmed as needed. And often when you talk about cryptography, the math that goes behind making everything work requires a lot of line count. So usually we go through a phase of trimming the code to make sure we have the functionality that we need, and then we can take the subset of the code base through certification. I think for this set of algorithms, you're looking at around 10,000 lines of code, roughly. And one thing about testing, the testing is unique to wolfSSL. That's our secret ingredient. And we do API testing, peer review testing, static analysis, memory leak checks, interoperability testing, Cypher suite testing, regression testing, many build option, OS. We test with different OSs, hardware acceleration. We test with different compilers like GCC F Sanitizer, Clang F Sanitizer. We test with third-party libraries. We do benchmarks and language wrapper tests. And wolfboot is a key component for cybersecurity, and it has been written for portability and ease of use. It's written in C, and it supports a multi-boot ELF Lynx support. And we've abstracted out HAL design for CPU speed and flash, small footprint, and specifically wolfboot DO178 supports 11th gen Intel Core i7, Intel Tiger Lake. It can run inside UEFI environment, then load and verify EFI application, supporting booting as an EFI application. And we also support other popular architecture, 32-bit, 64-bit, Intel, RISC-V, RPC, ARM. And wolfboot features, the underpinning cryptography has gone through FIPS 140-2 certified and FIPS 140-3 ongoing, and DO178C DAL-A certified as well. And you have a number of options for asymmetric verifying. You can use ECC RSA at 25519 or at 448. And as public key-based root of trust, we support multiple keys. In loader handles update between partitions, is failure, update failure, rollback, and version downgrade protection. And it supports external flash if your microcontroller doesn't have enough flash. It supports bootloader self-update, encrypted update, delta updates as well. And the way you manage the keys in wolfboot is you generate keys once, and the private key always lives on your server, and the public key is stored on a target for bootloader access. And the signer tool attaches a manifest header to the image. Then the manifest used to validate image integrity and authenticity depending on the algorithms that you've selected. And if it is all good, then you can run the verified image. And wolfboot relies on trust anchor to embed the public key used to verify the signature. And wolfboot is currently going through DO178C DAL-A certification for secure boot on 11th gen Intel Core. And these are a list of the files in the certification boundary. And you're looking at around like 22,000 lines of code. And we're really excited about that one. In the use cases for a specific customer, and the customer needed to verify all components used in the boot process, interaction with SATA drive for secure disk unlocking, and we leverage one of our product, which is a TPM 2.0 software stack to do sealing and unsealing disk secret based on system measurement. And they require PCI dynamic enumeration with runtime discovery, and want us to use Intel Boot Guard, as well as support multiple operating system protocols. And the FSP is responsible for initializing memory controller and preparing memory sections. It's in charge of silicon initialization, and it completes an easy customization of the silicon. And the Intel Boot Guard provides root of trust, and it requires a few Intel specific ingredients as well. And there is a requirement for bootloader support for dynamic device enumeration. And we made that happen. So this is a diagram of who verifies what. So Wolf Boot is used in stage 1 as well as stage 2. During a reset vector, Wolf Boot stage 1 runs and is verified by Intel Boot Guard. The ones on green are, and the firmware support package is verified by Intel Boot Guard, and Intel Boot Guard transfers control to Wolf Boot stage 2, which is verified by the Wolf Boot stage 1. And finally, when you have a kernel like Lynx or any other OS kernel, that is verified by the stage 2 bootloader. So you may be asking, why use Wolfboot? Wolfboot was modified to replace Intel Slim Boot. Number one is performance, because we could leverage accelerators such as SHA-2 256 or SHA-2 384, and faster encryption and decryption to use the Intel AES-NI. And it's similar for other hardware architectures that provide acceleration. We can plug into it. We're a pure C library, but we do have assembly optimization. We do have, if you've got a crypto accelerator, we can plug and accelerate the crypto operations as well. And if you want to certify DO-170AC, our WolfCrypt has already gone through DO-170AC certification, so you can leverage that. And really, the main one is the ability to integrate the special features into your boot sequence, because we replaced Intel Slim bootloader. You can use WolfBoot as a second stage bootloader, and you can use seal and unseal password from TPM to unlock SATA drive and boot the OS image that way. So you've got added security. So WolfBoot plus WolfBoot is the only DO-170AC certified secure bootloader solution available today that we know of. If you do know some other vendors which have this, please let us know. And the reason why you want to replace your existing bootloader is if you need DO-170AC certified crypto, if you want to use FIPS 140-2 validated cryptography, CAVP or ACVP validated cryptography, if you want to leverage hardware-based cryptography or platform-specific assembly, if you want to store your keys and use TPM solution, which nicely integrates and plugs with our cryptography as well as WolfBoot, and if you want to have a customizable boot process integration. And with that, I would be open for question, I guess, at the end, and I'll transfer the control to the next presenter. Thank you.
Hi, Doug. You're
Okay.
also on mute. There you go.
Yep.
Fantastic.
Sorry.
Thank you.
Okay. So it's a real pleasure to meet. My computer grinding to a painful halt. Hopefully, can you guys see my screen?
Yeah, but you're not in presentation mode yet, Doug. So
My computer believes it's sharing.
it's definitely
Oh,
sharing,
right.
but we're seeing the whole of PowerPoint.
Yep. Sorry. Okay.
Thank you.
Thank you. So I'm going to focus on, a slice of the topics that have been discussed so far, and this is, increasing resilience and reducing risk through some cyber mitigations that can get added into the software itself. And how those mitigations can have an impact on cost risk, schedule risk, and operating risk. So RunSafe focuses on a vein of cyber issues known as memory safety flaws. And the memory safety is an important issue in C and C++, which is the vast majority of code used in the embedded space. Rust is coming, but for most projects, it's going to be 8 to 15 years before it's a predominant portion of the code. In C and C++, about a third of the instructions relate to memory, lookups, writes, computations, and depending on some of the statistics, there are a couple of references to this. For every 1,000 lines of code, there tend to be 7 to 15 vulnerabilities. And statistically, in C and C++, 50 to 70% of those bugs relate to memory safety. And in a 20,000 line program, you're looking at a couple hundred vulns. Fixing the vulns takes on average 126 to 180 days. wolfSSL moving at 36 hours is fantastic. And congrats on that statistic. And even with that fantastic performance on their part, this statistic also relates to sometimes how long it takes to get fielded. What's also fascinating is how long testing can miss bugs. They can lay dormant for decades, and every year there are examples of bugs that have been present in code for 17, 20 years, and then have been weaponized for some portion of that time, but just not known publicly. So in a 10,000 line program, the delays from bugs can be months and cost millions. And the NSA, Department of Homeland Security, White House, and Congress are all pushing to kind of find a way to fix these bugs, both known and unknown. So by partnering with Mosaic, what we've been able to do is help reduce risk even before the vuln is known. So by laying RunSafe mitigation in without changing your compiler, without changing your software, a line of software, anything, we're able to cut off an attacker's ability to exploit effectively 100% of memory safety weaknesses. Now, the important thing here is that this is for known and unknown vulns. Our mitigation doesn't need to be told what's vulnerable. Simply, we assume everything's vulnerable. And we know all the places that an attacker is going to try and attack because it's discernible from the program. And so we make it so that an attacker can't do it. And what we've been able to show is that this reduces the number of patches, fixes, and downtime that operators have because they don't need to panic response to the latest 0-day because they can tell their customers, hey, a new vulnerability has been identified, but you have effectively no exploitation risk. So fix that at the next reasonable time. And what we've also been able to show is that this has a statistically unmeasurable impact on system performance. And statistically unmeasurable means that it is never, in no use case has it ever been more, has it ever exceeded a standard deviation plus or minus of the existing behavior. So very compelling. And again, there's no NRE on our part. This is a commercial software tool. You just drop it in. If for those who use like Yocto, Buildroot, or other things like that, it's literally just a layer that gets added, and you're now, everything you compile has this protection built in with no changes. So, and it frees up, millions of dollars and thousands of developer hours. And our customers in the Navy, Air Force, and other places have been able to positively identify, dozens of labor years that they've freed up just by including this. And again, you get resilience, zero-day mitigation, and you get protection that starts the moment the system's deployed. So it doesn't begin the moment a new bug is discovered. It began the moment the software was deployed, period. So what do we do? RunSafe Security's code product, we mitigate the exploitation. We randomize the locations of code in memory. And we do it at the function level instead of at the library level. And so ASLR, address space layout randomization, a technique that was introduced in the 2006-ish timeframe, is now relatively common. I think it's not present in 178 systems typically, but it randomizes the base address of a library, but still the entire library, which is going to be several megabytes of code, typically library or executable, still loads contiguously, giving the attacker, still a deterministic layout of the tools they need for an attack. What RunSafe does is we randomize at the function level. And an analysis of thousands of programs has shown that the average program has 288 functions. And so that gives you roughly 288 factorial, possibilities, which is, more than the, particles in the universe type of, coverage. So it can get compiled into, Lynx OS, the unit kernel, bare metal, the customer apps on Lynx OS. And then this is achieved with no changes to the code. And we don't need to keep pushing updates to people's build tools. And so the way we do this is, we go from your source, and this can also work with Rust. And if you have other things that aren't CNC++, this has no impact on those. You can continue to operate as normal. But things would normally, with RunSafe not present, go through the .o files. The precompiler would spit out the .os, and then you would proceed through linking, and you'd have this unprotected binary. RunSafe, we take this path to the south where our load time function randomization, it gets added by analyzing the .o files. We analyze it for function sizes, locations, and cross-references. And we tack that information onto the end of the .o file as metadata. And then we proceed to system linking as we normally would, and we now have a library that gets added to it, our library. And so the basic function of the software is that instead of the binary jumping to the main.c's entry point, it jumps to a pre-main that we've added that does the randomization every time the binary is copied into memory. And then we turn it back over to main.c. And then the execution proceeds as normal from there. And the implication is that explains intuitively why we have no impact on performance, because our protection happens all before the binary starts executing. We tend to add about 1% to process setup time. So if something took a minute, a second to load, it now takes 1.01 seconds, or a minute, it takes, 1.01 minutes. And again, there are some example vulnerabilities in a commercial RTOS that, the vulnerabilities were present for 13 years, have hacked stack overflows, heap overflows, integer underflows. There was a PPP daemon bug, very popular one, 17 years old. It had buffer overflows, and both allowed remote code execution. And they were in, aircraft systems, manufacturing, et cetera, industrial control systems. And, to our RunSafe protected customers, they were protected, not just when those bugs became known, but when they deployed. So what about DO 178C 330 and then DO 326 356? So we are DALE certifiable and TQL1 verifiable. We have a small body of code, less than 20,000 lines of source, and we're deterministic behavior. So there's two components. We have an on-wing component that is certified TQL1, and then we have a build time component that is DAL-A. And then, we're creating the tool artifacts, the operating requirements, the tool qualification plan, and the various high-level requirements. And then what's also important is that as DO 326 and 356 increase in prevalence, we help with at least 2 of the 14 cyber principles for the PSEC Act, defense in depth and ease of maintenance. So, and here's just an example of what integrating it, here's some additions you'd make to build root process, some changes of what build root make files would look like. So that's it for me.
Thank you, Doug. Thank you, Justin. Thank you, Tesfa. A couple of questions did come in, but actually I believe, Justin, you replied to the first one, which was directed at you, and Tesfa, you've replied to the one that's coming for you. So appreciate that. I guess we give people the opportunity to put in a couple more questions. Well, we've got about a few minutes, 10 minutes or so left of this webinar. So if you've got any questions, please put them into the Q&A channel. In the meantime, I'd like to ask you all really a question that relates effectively to what this webinar is all about. I mean, obviously you've given us a lot of information about specific products, but if you personally wished to list the best practices, say the top 3 best practices that you would use with regard to cybersecurity resiliency in the systems architecture, what would those be? Justin, I'll put this to you first, as you were speaking first.
Absolutely. I think the first thing that comes to mind, which I've always had to, I think, sort of champion, especially on the customer side within the government project offices, is that over designing for the sake of most just a cybersecurity can be a reality, right? So given cost, schedule, risk implications that typically dominate an acquisition, one of the first things I always try to do with any customer and any platform is make sure we understand the operational use case of the system that they're building. So, for example, if the weapon system doesn't call for something like a honeypot to be in it, right? You have a firm use case understanding of why you're not doing that, and you have, I guess, the more compelling protections clearly identified. And when you can start at a use case level, it's much easier to inform derivation and decomp of requirements, and not only the top level, but down to the individual component boundary, especially when we're talking like a computer software configuration item boundary that has stringent requirements like D178C. And now, as Doug mentioned, 326, 356 are coming along. So that's one of the first things I would do. Defense in depth is absolutely, I think, the most stereotypical 101 thing you could ask for, but it can't be one option. So it has to be many layers to an onion, as everybody knows. The other comment about baking it in rather than bolting it on, that's why I push to a more systems engineering approach with how I recommend a more cyber resilient system. Because if it doesn't make its way in terms of your spec tree, it's going to take the back seat when things get tough for the acquisition. Funding profiles change, schedules change, new risk gets introduced, and sometimes, especially in the DoD space, it's just hard enough to get to the next milestone or get, like in my case, get the aircraft in the air, right? So I think that those are the two that really jump out to me the most. And I'm curious to see what the other guys think as well.
Thank you. Tesfa, what would be your sort of top 2 or 3 best practices?
From a cryptography point of view, when we sit with customer, we want to make sure that they understand cryptography basics, and we want to make sure that they use proven algorithms with stronger key size, depending on their performance requirement. We advise avoid implementing cryptography yourself, and select up-to-date libraries. In terms of key management, for your keys, for your private keys, you need to protect it very well. If you can, use a TPM, Trusted Platform Module, and do key rotation. The fundamental one is the RNG, secure random number generation. So you want to make sure you've got the secure RNG and for all the cryptography to work, right? Generally in terms of delivering software, we want to make sure that it's either encrypted. So on the receiving side, we use secure SFTP or something like that, and then they can verify hash of what we deliver. So nothing get introduced in between. What else? I think that's, stay up to date on cryptography, trend and vulnerability. Because if there is a vulnerability fix, you want to run the latest and greatest, and use something that has gone through some kind of compliance. Like our cryptography has gone through FIPS 140-2 and FIPS 140-3. So I think those are the things that we want our customers to be aware of when they think about cybersecurity system architecture, and they want to protect data at rest or in motion.
Excellent. Thank you, Tesfa. Doug, your top 3 best practices.
The most important is secure your open source. Open source is an indomitable force in software these days, and do something. And this is a key tenet of secure by design principles. Do something and secure, like the DO, or not DO, but in NIST 800-218, I think the secure software development framework is how to, secure, make the open sources coming in do something that is different, that will confuse an attacker on your use of open source. Because if you do what everyone else does on open source, you do the lay practitioner does with open source, then all that open source is an open book to your attacker. So that's key thing that we see can really change the security posture.
Thank you, Doug. I've just seen another question just come in right now. How challenging would redeploy existing applications using the new protected binary files be? I'm not quite sure who that was aimed at.
So it's no different than pushing an update. So you recompile and then you push. That's the extent of it. So whatever your normal redeployment processes are, you would use that same connective tissue. The binaries, they're no more or less fragile than your previous ones. They now have this extra intelligence in them that lets them they creates a form of memory moving target defense.
Thank you, Doug. I'll just throw one more in before we run out of time here. AI is not new in the military environment. I was looking at it myself back in the 80s, so decades ago. But the AI is the big buzz nowadays. I don't know if you guys want to pitch in about, are there any specific threats that are appearing now with the increased use of AI applications across the board? I guess not so much for embedded systems, but in other parts of the systems architecture. Anybody want to take that one?
I think where my mind goes to is there's a lot of publicly available open source information on products that are have a deep breadth of collateral. I'd say marketing collateral for the DoD space. And one thing that worries me is the reverse engineering element of this. And these are where the learning models are even used today, right? I mean, a lot of the explicit threat information is going to be high side, but just in terms of the products and how we broadcast them and advertise them and what we reveal to customers in the government, it's at risk of essentially going into a learning model at an adversary's, home, essentially at this place, at this stage. So that's something new in addition to just the actual threat when it gets, flash to bang, either kinetic or non-kinetic in a, actual operational scenario. But most of all that work is on the front end, right? I think anybody who's taken like a threat intel brief, in the open or with a company, you're going to see academic is where they tend to focus, followed by DoD. So that's one concern we have to make sure we have a response to, and some of that looks like fighting fire with fire. Over.
Right, thank you, Justin. Tesfa, I don't know if AI is posing any specific threats in the crypto world. Do you see anything new coming in on that front that's causing you issues?
Well, AI is great. It helps you expedite things in terms of, like, say, documentation as an example. It's good to use it. But AI alone, if you rely on what AI outputs, and that's a dangerous position to be in. So we don't have a specific threat per se, but our cryptography is open source, as well as commercial. So as open source software, our software has been looked at by government, academia, the industry, testing the hell out of it, and everything that all changes that go in are closely monitored. So it's not, AI doesn't really directly affect us per se, but who knows, 5-10 years from now.
Indeed. Doug, is there anything you'd like to say about AI or the threats that could rise from AI?
One of the things that we've noticed is that a lot of people who think about their security risks, they think of the security risks only in terms of the people that they hire. Meaning, if they hire a lot of Python developers, they think their cybersecurity risk is Python risk. SQL injection and cross-site scripting and things like that. What's easy to forget is that Python, artificial intelligence, all of these snippets of code run on top of tens and tens of millions of compiled code software. There is no bare metal AI. And so it's very easy to forget that the libraries that support AI, the libraries that make those computations possible, again, they all at some point translate into native code, and those models and things, have a set of vulnerabilities that, even though you're not hiring C and C++ developers, you need your threats. You need to keep paying attention to the fact that the systems running everything have a set of exposures that you may not be tracking. So keep that in mind in your calculus.
Thank you very much, Doug. Okay, I think we're pretty much out of time now, folks. So thank you all for joining us today. Thank you, Justin, Pearson, Doug Britton, and Tesfa Mael. Appreciate your time. This session is being recorded, and the recording, together with the slide decks, will be made available in the Open Groups online library, probably by Monday, Tuesday of next week. So thank you all, and we will no doubt continue this series of industry webinars in the future. Thanks very much indeed, everybody.
Thank you.
Thank you.